So good morning, chemistry second year, English medium. Unit is organic compounds containing carbon, hydrogen, oxygen. So topic is preparation of alcohols. Already we started the alcohols topic. So today discuss the preparation methods of alcohols. So various preparation methods are used to prepare alcohols, in which the first one is here is from alkenes. Then next one is here is then Grignard reagents. Third one is from carbonyl compounds. So we can prepare the alcohols. Let's see the from alcohols. So in which the first method is by acid catalyzed hydration. By acid catalyzed hydration. Yes, how alcohols are prepared by taking here is alkenes is in presence of acid. In presence of acid, here is alkenes can interact with water. Alkenes can interact with water to form alcohols. Okay, that's why this is acid catalyzed hydration. Hydration means what? Addition of water. Yes, sir, this addition of water is taking place in presence of acid. That may be here is a H2SO4. Okay, dilute H2SO4. Then here is a alkenes can interact with water and form the here is a alcohols. So this is called as here is a acid catalyzed hydration. Here is a acid act as catalyst. Hydration means what? Addition of water to alkenes. Yes, so let's see how the mechanism. So this is a general formula of alkene. When interact with water in presence of acid, here is a alcohol is formed. Alcohol is formed. Then yes, suppose here is an example is what is a propene. Propene in presence of acidic media, it can interact with water and form the yes, a propane 2-ol. Propane 2-ol is formed. So the formation of propane 2-ol is by the according to is a Markovnikov's rule. Markovnikov rule. So this Markovnikov rule already discussed in first year. Okay, then yes, when unsymmetrical alkene interact with water in presence of acid, here is a in general here is a alkenes are electron rich species. Here pi bond is there, electron rich species. That's why it is involved in alkenes involved in electrophilic addition reactions. Okay, then yes, when electrophile, this H plus act as electrophile, electron deficient species. H plus ion is electron deficient species. That's why it act as electrophile. This electrophile interact with the alkene. Okay, yes, sir, this alkene where the pi electron cloud is existed, then yes, it may interact with this carbon or it may interact with this carbon. When H plus or electrophile attacks on the yes, this carbon, less substituted carbon, then what happens is then secondary carbocation is formed. The secondary carbocation is more stable. That's why the secondary carbocation easily interact with the is a nucleophile. That is here is a water molecule and forms the here is a propane 2-ol. So this is according to M rule or Markovnikov rule. Markovnikov rule. Markovnikov rule. Okay, according to Markovnikov rule, is a propane 2-ol is formed. Then is a first mechanism is step 1 is a protonation of alkene to form carbocation by electrophilic attack of H3O plus. Then yes, in this reaction is carried out in presence of acidic medium. Okay, yes, here is a dilute acids. Here is what acid This acid interact with H plus ion. In general, acids gives the H plus ions. Yes, so this H plus ion act as an electrophile. Then this electrophile attacks on the water molecule because of its high electron density. That's why here is a H3O plus is formed. This is called as a, here is a electrophile. Here is a protonation of alkene to form carbocation by electrophilic attack of H3O plus hydronium ion. This hydronium ion act as electrophile. In general, H plus ions in general they are not in free state. Always it tries to interact with the water molecule and forms the hydronium ion. This hydronium ion act as a electrophile. Then so this electrophile attacks on the alkene. Yes, here is a alkene is an electron rich species. That's why the pi electron cloud attacks. The pi electron cloud, yes, takes the proton from the hydronium ion H3O plus. Then yes, this is a slow reaction. This is a slow reaction. As a result of that, carbocation is formed. Carbocation means what? Yes, the species which is having the positive charge at carbon, then that is called as is a carbocation. Okay, so this species at carbon is a positive charge is generated. That's why this is a carbocation. Okay, carbocation is formed. In first step, carbocation is formed. Carbocation is formed. Then next step, nucleophilic attack of H2O on carbocation. Yes, so this is considered as here is a carbocation. This carbocation is attacked by the water molecule. So this water molecule is electron rich species. That's why yes, the lone pair of electrons present on oxygen attacks on the is a carbocation. Then as a result of that, next one, yes, here is intermediate. Here is a intermediate is formed. Okay, then intermediate is formed. So this intermediate, then it is unstable. Then yes, as a result of that, in presence of here is water is available in the reaction medium. Then so it loses the proton. This intermediate loses the proton. This proton is absorbed by the water molecule and forms the alcohol. This is the water molecule act as a nucleophile. Then protonation to form alcohol. Then it act as a nucleophile, electron rich species. That's why then again here is a proton is abstracted from the intermediate. Then here is a alcohol is formed. Then H3O plus hydronium ion is as usual. Okay. Then again here is a proton is removed. At first here is a proton is involved in the reaction. After formation of alcohol, what happens? Then the proton is removed. Simply here is a water molecule is added to the alkene and form the alcohol. Okay, so this reaction is carried out in presence of acidic medium. That's why this is acid catalyzed hydration reaction. Simply, so this reaction is carried out in 3 steps. In first step, here is a carbocation formation takes place. How? Then, so by attacking of H3O plus ion. Okay, electrophile attacks on the alkene and forms the carbocation. So this carbocation interacts with the nucleophile, that is water molecule. Then as a result of that, then so this intermediate loses H plus ion. Then here is a alcohol is formed. This reaction takes the 3 steps. Then so this is according to there is a Markovnikov rule. Then again, suppose if a simple symmetrical alkene is there, symmetrical alkene, the both 2 carbons are same. Then that's why yes, there is no change in the formation of alcohol. When unsymmetrical alkene involved in the acid catalyzed hydration reaction, then yes, most probably here is a secondary carbocation. Secondary carbocation is formed because the secondary carbocation is more stable when compared with the primary carbocation. Then so because of attacking of electrophile on alkene, secondary carbocation is formed as excess amount. Okay, so this secondary carbocation interacts with the nucleophile, that is water molecule, and forms the here is a alcohol. Okay, then so this is the here is what secondary alcohol is formed. Okay, according to Markovnikov rule, then so this is the secondary alcohol. Propane 2-ol is secondary alcohol. When symmetrical alkene involved in acid catalyzed hydration reaction, simply here is what primary alcohol. Primary alcohol is formed. Then next one, so this is the unsymmetrical alkene. Yes, secondary alcohol is formed. Then another one is there is a alkenes. When alkenes undergoes hydroboration reaction followed by oxidation, then we can expect the alcohol. We can expect the alcohol. Hydroboration. Hydroboration means what? Then alkene interacts with a borane, that is BH3. In general, BH3 is existed as in the form of a dimer, that is a diborane. Okay, diborane, but the diborane is somewhat stable when compared with there is a monomer, that is a BH3. That's why we are taking a BH3 form. Okay, BH3 form. Then diborane, so when compared with the monomer BH3, diborane is more stable. Diborane is more stable. Yes, in general it is existed in the form of BH3, 2 moles of BH3 with yes, 1 mole of diborane. That's why the more active species is BH3 form. That's why we are taking a BH3. Then so BH3 is in the form of a dimeric condition to this. Then yes, here is a alkene. Yes, here is a boron. So boron is a electron deficient species, that is a Lewis acid, because at the boron atom there is a empty orbital is present. Empty orbital. So that's why it is a trivalent molecule. It is a trivalent molecule. It is electron deficient molecule. Okay, it doesn't obey the octet rule. Then because of the presence of empty orbital, it acts as electrophile. Okay, it's a neutral electrophile. BH3 acts as a neutral electrophile. Then yes, this is a alkene is considered as because of the presence of pi electron cloud. So this act as here is a nucleophile. Then the pi electron cloud first of all attacks on the BH3, especially on boron atom. As a result of that, it is getting a tetravalent. Then as a tetravalent, then here is a because of that it is getting positive charge here. Okay, positive charge here. That's why this BH3 loses the hydrogen as hydride form. Okay, H minus hydride form. It attacks on the carbon which is having the positive charge. Then this is the way CH3 CH2. This hydrogen from the BH3. Okay, then next one is BH2. Then it is connected with here is a BH2. This is a positive charged species. Okay, BH2. Here is a BH2. In general, it is attached with the less substituted carbon. Then yes, this hydroboration reaction follows the anti-Markovnikov rule. Okay, then yes, here is a hydrogen is in general added to the here is a less hydrogen containing carbon. In Markovnikov rule, according to Markovnikov rule, in general here is a this is a hydrogen is added to the carbon which is having the more hydrogens, more rich becomes richest. Okay, that's why, so this is the hydroboration reaction is follows the anti-Markovnikov rule. Then next one again, here is this is the, it is a tetravalent here, then again here is a empty orbital is there, then next one is again another mole of alkene is involved in the reaction, then the pi electron cloud attacks on the boron, yes. Then next one again here is it loses the hydrogen as hydride, this hydride attacks on the carbon which is having less hydrogens, anti-Markovnikov rule. Then next one again here is it is, yes, one more hydrogen is there on boron, that's again here is what, another mole of alkane is involved in the reaction. Then yes, next one hydride ion is transferred from boron to, say, alkyl substituted boron to, here is what, here is a alkene, then the trialkyl boron is formed. Okay, so trialkyl boron, which alkyl, here is a what, here is a propyl, is a CH3, CH2, CH2. Okay, yes, the tripropyl, here is a B has, instead of 3 hydrogens, 3 alkyl groups are there. Okay, so that's why here is a trialkyl boron is formed, trialkyl boron. This trialkyl boron undergoes the oxidation in presence of hydrogen peroxide and here is what, aqueous sodium hydroxide. Aqueous sodium hydroxide in presence of base. Okay, then the H2O2 act as oxidizing agent. Then so this reaction is carried out in presence of basic media, that is aqueous sodium hydroxide. Then what happens? Trialkyl boron is oxidized to alcohols, that is N-propyl alcohol or propane 1-ol, propane 1-ol or N-propyl alcohol is formed. Then next one is H3BO3, boric acid is formed, boric acid. Okay, then yes, this formation of N-propyl alcohol is based on the anti-Markovnikov rule, anti-Markovnikov rule. Hydroboration reaction, hydroboration followed by oxidation, so it follows the anti-Markovnikov rule. Hydroboration means what? Yes, simply when alkene interacts with boron to form trialkyl boron, that is called as hydroboration. This trialkyl boron involved in oxidation in presence of hydrogen peroxide and aqueous sodium hydroxide, then it causes to form alcohol or primary alcohol or N-propyl alcohol or propane 1-ol is formed. Okay, so this is about hydroboration reaction. Okay, hydroboration reaction. Then